Hello everyone and welcome to the second day of the LightCon preview week. My name is Maria Christina Miem. I'm the LightCon project director at Deutsche Messe. Today it's the 23rd June and right now we would have opened the doors to our new International Congress Trade Fair LightCon, the first cross-material and cross-technology platform for lightweight solutions for all user industries. We would have had if the Corona crisis didn't force us to postpone the premiere, but as so often, new opportunities arise. So I am really glad that we can at least meet virtually today. And yeah, as far as I can see, we have already more than 100 participants. That is great. And hopefully next year on 23rd and 24th June, we can welcome you all here in sunny Hanover. So with the LightCon preview week, we would like to give you a small foretaste of what LightCon 2021 will be all about in the conference program, but in the exhibition as well. So stay curious. And for today, I hope you will enjoy the webinar. Thanks a lot for being with us. And special thanks to Tassilo Witte, our speaker, for sharing some of his insights with us. And last not least, I would also like to thank our founding partner, Composites United, for the great cooperation and the support in organizing this event. Before we start, I would like to hand over to Dr. Merz from Composites United, right?
Yes, good morning, a warm welcome also from my side on behalf of Composites United. As Mrs. Miem was saying already today, we had originally planned the opening ceremony of the first LightCon in Hanover with our partner Deutsche Messe AG. Beside top lectures, you would have experienced an exciting exhibition with customer-oriented lightweight solutions. Tonight, we would have celebrated a fantastic evening event and the European Football Championship in parallel. The weather would be perfect. We were ready, but unfortunately, we have to postpone the realization of nearly all our plans and also the first LightCon to next year. However, as we were ready and had a fantastic program in place, we want to present to you now some highlights out of this program to give you on the one side an impression of the quality of lectures you can expect from LightCon, and on the other side to shorten the time until we can meet next year in Hanover face-to-face. We think that the concept of LightCon is a perfect fit to address all requirements for value creation by lightweight technology. Lightweight technology is a key technology based on the new strategy of Composites United and also based on the strategy of the German Ministry of Economics. The overwhelming participation in this LightCon preview week is a proof for the importance of this technology. There are about 1,000 registrations for the LightCon preview week. This is fantastic. And I would like to thank you, especially now today, participating in this very important lecture. Enjoy the lecture.
Thank you very much for this nice introduction, and thank you very much for giving me the chance to speak here and to do this little presentation and talk a little bit about the manufacturing, or more specifically sustainability in aircraft manufacturing and how we approach this topic in general. Because if we're talking about sustainability in aircraft manufacturing, there are actually two major questions or two major parts that I want to talk about today. The first is how to know that we are doing the right thing. And the second is what we actually do to increase the sustainability, specifically of composites right now and these days. And to know how to know that we are doing the right thing is one of the most crucial questions for us at the moment. Because how do we assess sustainability at the moment? I don't think I'm telling you anything new, that at the moment the life cycle assessments in general is the crucial tool for that. And we're looking at the different branches and the different industries, and specifically at the different life cycle phases. And for us, it is not only a matter of manufacturing, sustainability in manufacturing, but sustainability of the entire life cycle phase. Because we have to be very careful if we do anything to a specific part, in our production phase, how this is going to impact the use phase of our aircraft. And especially after that, how do we do the recycling of such materials, specifically the composites that we've been using so much in the last decade at least, using it since 1980s in the VTPs of our aircraft. And still at the moment, this is a material that only recently has been solved on how to recycle these materials. So right now, the question that we are asking us is, how do we assess and what is the ecological impact of the manufacturing of an aircraft? And approaching with, let's say, standard life cycle assessment tools, we're currently trying, or we have been in the past trying to track down the material breakdown of our former aircraft, like the A320, A330, and at the moment doing the same thing for the most recent aircraft, the A350, that is basically 53% composite materials. And if we look at that, we're trying to look at the materials that go and the energy that go into component manufacturing, what logistic aspects we have, what fuel use in the operations phase we have, what maintenance, the airport construction, and I'll go a little bit deeper into that because this is not a usual aspect of life cycle assessment, and what kind of end-of-life scenarios we have. And we can get to a very specific material breakdown for each of our aircraft. So we can very clearly say what they consist of and how you can take apart each element of this aircraft and try to recycle it in the best manner possible. And because we've been talking about aircraft sometimes not in the best light in the past, I just wanted to give you a little bit of an actual clue on what the consumption of an aircraft or the use of flying aircraft is. Because in the end, it comes down to the aircraft efficiency and the passengers we have. And a couple of other aspects that I'm going to dive into in a couple of slides later. But just to get these numbers into your heads, I'm comparing here two types of data sets, one from the Lufthansa, which is, let's say, practical data, and one from the DLR, which is, I'd call academia data. And both of these values, so data set one, short haul from Berlin to Köln, with roughly 5.39 liters per person, 100 person kilometers. And this is just the typical value that you would probably see in a car, because it's how many liters of fuel do we burn per 100 kilometers per person, since we do carry a little bit more than the 5 people we carry around in our cars. And I think the interesting thing here to see is that, first of all, the short hauls consume a little bit more than the long hauls due to the overall efficiency of the aircraft and the flight itself. And the range that we are talking about, that we're between 4 and 5.4 liters, and that both these data sets are pretty much the same values that we are seeing here. So I think it's nice to know that we're not talking about like 20 liters per 100 kilometers, but it's actually in the range of a very efficient modern car that we're talking about. And this has been developing in a lot in the past. The first aircraft have been much less efficient, but with the recent A350-800-900-1000, we are ranging, getting to kind of a plateau on what we can do in terms of efficiency. And at the moment, this is a lot attributed to the aerodynamics of the aircraft, but mostly, and this is very crucial, mostly attributed to the engine efficiency, since that is where we burn most of the fuel, where we burn our fuel. But what I wanted to have us think a little bit about as well is that in the typical life cycle assessment that we are talking about, we're mostly talking about the production phase, the use phase, the recycling phase, but very little about the actual infrastructure. And this is one of the aspects where, while having a couple of other drawbacks, the aviation industry really has some advantages, especially if we're talking about regions where you don't have anything else to travel on. And the idea that I was always pondering there is imagining an island and a couple of people sitting down and having like these palm leaves, and all of a sudden one of these palm leaves would, two such palm leaves would grow together, and they have basically realized that, wow, when the wind is blowing over there, there's some lift, and a couple of hundred years later, they have developed a whole entire civilization that's just flying around. And just think, how would the world around us look if we don't have any roads, if we don't have any such influence in our environment, in our surroundings? And that was what made me think that we need to assess the infrastructural impact of our different methods of transportation a little bit more. But to be honest, this is not an easy task, because if we want to do life cycle assessment on that frame, you got to get the data for that, and you got to get the people to work on that. And the challenge is mostly that we're talking about two different ranges of a different huge range of analysis that we want to do. So we don't want to do this only from the beginning of our production cycle to the end of our production cycle, or from the beginning of the production cycle to the recycling of the part later on, but we want to do it cradle to cradle, and we want to do it in the best case not only cradle to cradle but in a circular economy, seeing how we can reuse the material, what the reuse and recycling aspect processes have for an impact. And that is currently what we are trying to achieve, trying to get a full overview. And the second point, and I have to say this is a little bit of a personal opinion in that we are having in our surrounding here, is a little bit of a dislike for the CO2 equivalents, and simply because they are, for me, not very tangible, and allow a little bit less comparison between a couple of different factors. And just here, when we try to interpret that, when we try to get a clear idea and compare it between different modes of travel, for example, the best thing that we found is energy, and talking about the accumulated energy value of such materials. And and luckily, there have been processes developed that, or methods and models developed that can actually assess the impact of the infrastructure on cars, on aircraft, and on trains. And this has been done to a certain extent. And I will in a second give you just this key idea, because this is just to comment a little bit on that. These are data from the US Transportation Research. They are US data, so they have a little bit of a different environment than we have here in Europe, meaning they have more air travel, more buses, and much less train travel, simply because train traveling is not that developed. And also, just to keep that in mind, they drive a little bit different style of cars than we do here. And this analysis has tried to take into account all these aspects that I've mentioned, not only the operation, the manufacturing, but also the logistics, the infrastructure, and everything around the vehicle. And just that, maybe that most important point that I wanted to point out here, or that I would like to hint you on, is that currently, when we're talking about the energy per person kilometer travel, we can compare different modes of transport here. And what they've done, and here it's very obviously pointed out, the one person traveling in a car, especially the one person traveling alone in an SUV in a city environment, is using up a lot of energy. And this is why I think we just keep in mind that sharing cars can actually be very, very beneficial overall, since you can even get an SUV down to be comparably efficient per person if you just share the car. But what we also wanted to point out, or what I like to point out, is that with a regional jet or single aisle aircraft, we're actually not far up top on this list, but we're somewhere in the good middle. And I think that was quite revealing for me when we found these kind of papers. I know that coming from that industry, probably have a little bit of a confirmation bias, but at least we can confirm these data from a couple of other sources as well, and that is at least a good idea good to have a proper view on this whole aspect of how do we assess the sustainability of the aircraft. But that is just to get you into the feeling of how this is generally being done and what aspects we are talking about, and to give you that don't drive alone in an SUV vibe. But we want to show you a little bit more specifically what we're doing at the moment, because simply said, in the end, it is mainly about what we can influence right now is mainly about those three phases: the production phase, the operation phase, the end of life phase. And for the operational phase, it is crucial what we do, because anything that is being done in the production phase will impact the operation phase throughout its entire life. And here we have a couple of aspects that we don't want to hear or we don't want to see when we're talking about sustainable aviation, because I know that everybody is complaining about the seat density that we have at the moment. But just imagine that within the same aircraft that has carried some roughly 190 aircraft 190 people 20 years ago, is now theoretically capable of carrying up to 240 something people. So that is within the same space, you would fit in a lot more people, bringing down the overall per person kilometer or per energy used per person a lot. And that is only through to a better and more efficient use of the aircraft itself. That's something that I personally have to remind myself next time that I will be sitting down in an aircraft and want to complain about anything there. Because this is the best thing we can do besides increasing the engine efficiency at the moment. Here, it's very simple. Thrust per kilogram of fuel is the crucial factor. And in the end, and this is what our industry and specifically the composite industry is about, the aircraft weight. Because in the end, it's aircraft net weight. Sure, that's something that we as an aircraft engineer have to tackle. It's the fuel, it's the passenger weight, it's consumables and cargo. This is what makes up the total travel weight. And as a passenger, as a human being that is trying to do something good for the environment, we have to think about what we actually do, since passenger weight, consumables and fuel are directly impacted by us, how we enter the aircraft, how much luggage we bring. But we all do all of this, and since we want to improve the aircraft ever more, the introduction of composites was one of the crucial factors in bringing the aircraft overall weight down. And here, and this is what I will be going into for a couple of minutes later on, in a second. The last thing here in this general area that I wanted to talk about is the problems that we're facing in improving the sustainability, because just take a couple of major aspects like the noise impact, the local air quality and the climate impact, and the different aspects of air travel that we can modify. Like we can engineer improved nacelles, can reduce the noise, but if we do that, everybody around the aircraft, around the airport will be happy, but it would lead to local worsening of the air quality and the climate in general due to more CO2 burn. And this way, I'm not going to go through this list. You will be provided this, and it's specifically, it's also coming from the DLR. So I would recommend you to check this out just to get an idea of what the difference, what the different elements are that we try to steer to be a very good, efficient aircraft, but where we have actual challenges and actual contradictions, what we can do. And to take this to a very clear example, we have the aircraft cabin, and this is one of my other areas that I'm working in a lot. Here we are talking a lot about the eco-efficiency of the cabin, and a very obvious first discussion point has been the introduction of natural fibers to replace the widely used glass fibers. Like, can't you use hemp fibers? Can't you use Sisal, whatever? Natural fibers, one of the, let's keep it to that general category. And the problem here is that, yes, of course, we can theoretically use natural fibers to replace glass fibers, but this would have, due to the low performance of these fibers, would have a direct impact on the sizing, on the designing of the part, resulting in a little bit heavier part. And this little bit heavier part is very likely to generate so much additional fuel burn, even if it's just a couple of 100 grams, that it's very, very hard to save everything that has been saved in the production phase through the operations phase of the aircraft, and not end up with something that has been, in the end, turns out to be worse than if we hadn't done anything. So on the other hand, we're talking about, for example, the introduction of bio-based resins to replace phenolic resins. And that is, just from my experience with people talking about it, that is much less sexy than using natural fibers in the aircraft. But it's something that has very little impact on our business, since the resins would act the same way as today's resins do, has additional benefits like equivalent weight, it is REACH compliant, which phenolic resins might not be in the future. And overall, we have benefit of this whole endeavor. And this is maybe a very good example of why we need to actually assess what we want to do, because what is obvious here might not be beneficial. And the last thing I want to do, and the last thing we want to do, is introduce something, do something to increase the sustainability of manufacturing, increase the sustainability of our parts, and end up being worse than before. So what do we do to improve the sustainability of composites right now? I'm not going to present you all the composite recycling activities that we've done. I would refer to another presentation that we've given in 2017, and that has been presented a couple times since then, basically showing all the matters that we do with recycling. So key factors: we know how to recycle composites, we know how to use pyrolysis to recover the carbon fibers, and currently the issue that we are trying to tackle is not recycling in general, but what to do with the material that comes out of it, because in the end we need to close the circle. And this is what you can see here: a lot of different investigations that have been trying to, that have in parts also worked out, because we're currently already using reused material in the aircraft. And specifically, for example, what we are reviving at the moment is the recycled cabin lining. We've worked on high performance materials, we've worked on uncured prepregs, putting them into sheet moldings, putting them into bulk molding compounds. We've worked with aircraft parts, we've worked with non-aircraft parts, very non-aircraft parts. And this is what we're trying to do at the moment. And the issue for us here is that the market is contradictory, because we have, for our market, for our aviation industry, we have a very high performance demand, but a very low volume that we might apply. But there are other markets that might have less high performance requirements. Maybe this is why we're targeting the interior at the moment. We can introduce recycled carbon fibers into the interior due to their lower performance requirement and the adequately higher amount of application. But the biggest market for any recovered such material is actually high in volume but low in performance. So filler materials, injection molding, short fiber reinforcement. In the worst case, it's even dust. But that is where most of the bulk would go. So what we are trying to bring this or improve this is work on the performance of these materials. The most important aspect that we're currently already working on together with Japanese partners is increasing the alignment of recycled fibers to have something that is close to or virgin carbon fiber. We're working with applications not in the aircraft, but in the manufacturing environment, since this is where we can very easily integrate this right away without any major qualification issue during the next years. One of the biggest project that we've initiated and that is running right now is the search for A350 end-of-life solutions, specifically working together with the European Union and the Clean Sky 2 organization. It was initiated that during the next 3 years there will be a project working on the specific aspect of how do we dismantle and how do we recycle the A350. And from there on, right now we go and dive into the manufacturing sites themselves. So we're trying to find out whether improving the insulation of factory is more beneficial than introducing the heating method, or basically getting a clear idea, developing a Sankey diagram of the energy flow of factories to get a clear idea of where the issues are, where the major energy consumers are, and to know that we are also in that area working at the right points. Then we have the aspect of recycling, because very little has been talked about composite recycling in the second or third generation of recycling, because at the moment we know that we can recover a short fiber from an endless fiber composite, but we have done little research about this, what happens with the recycled parts that's going to be recycled again. How can we avoid degradation of the fiber length as much as possible? Or if we cannot avoid it, how do we treat this? And going down that same slope, in the end, there will be some kind of materials that we won't be able to recycle. And there's some material that is maybe heavily polluted, maybe more or less grinded down to dust. And there will be some kind of CFRP that we need to dispose of safely and securely and as we can. And as recent investigations have shown, this is something where there's also a little bit need for work on. And just summing up, giving you last little overview before coming to an end here. If we're talking about this whole issue, we're talking about in the typical manner of the reduce waste hierarchy. And what we're currently targeting is, well, reduce, that's very obvious. That's something that has a direct impact on our own business. That's something we're doing intrinsically. But the reuse and the recycling market had to be developed and have still to be developed. And this means at the moment, and we're talking a lot about non-aerospace application and non-flying application, and very slowly starting to get actual flying aircraft and flying recycled materials into the aircraft. What has been very little investigated is the recovery, and well, due to recent findings, the area of disposal will have to be reopened. And it's simple. We do net shape manufacturing. We increase the carbon fiber manufacturing itself, so direct heating input, increase the throughput of such materials. For the reuse, we're talking about marketplaces where we can offer what is my waste could be your raw material. Maybe we're trying to improve on that direct reuse technologies. Especially the focus is on indirect production facilities, so toolings, jigs, because we use that a lot, and we use it a lot in carbon fiber as well. For the recycling, to be honest, the biggest issue is the acceptance of customers, of the companies, of the OEMs, because most likely you know that we don't have an issue with the fiber itself. We know what kind of performance this fiber would bring. And we have a huge amount of ideas of what we can do with this. Just in the recent past, my personal opinion was that there has simply been too little willingness to introduce these materials and to actually tackle these challenges that we have when we introduce the recycled materials, maybe because it might have a little bit less stable supply chain than we have for virgin materials that have been in use for 20 years. But this is something, finally, these years we are talking about actually covering these challenges. And at the moment, I'm pretty happy that we are starting to actually use recycled carbon fibers right now in the production environment. And what I just wanted to remind us all is that we shouldn't forget the auxiliary materials recycling or reuse, since that is an area that I've seen very little discussion going on about, but in terms of the waste amount is crucial, because we are talking about nicely recycled composites while producing a huge amount of plastic waste. Recovery has also been almost no research in the recent past. This is just something I would wanted to highlight here, because it is a part of our waste hierarchy, and while not being what we really want to do, for some elements it might be one of the only things that we can do, because it boils down to an elemental recovery of the materials. And this is what we could do. Instead of just trying to improve the burning of our CFRP waste, we could try to tackle the elemental recovery of these materials. And well, the final issue is the disposal. At the moment, we are assuming that co-incineration in calcium carbide plants is the only feasible route of recycling or of disposing carbon fibers. But we are also working in different other areas, because specifically for example, most interesting for me is looking at the microbial degradation of organic wastes, the resins, to be able to talk about something like a CFRP compost. And this is actually feasible. This has been shown for PET materials that can do this, and now it might be possible for composite waste as well. Yeah, and to bring this a little bit to an end, life cycle assessment, while sounding less sexy than bio-based materials, is a crucial tool. And I need to remind this myself. I originally wasn't too much of a fan of this whole LCA movement, but really it is the tool that we need to use to assess if we are doing the right thing. And for an aircraft, for sustainable aviation, this means looking at the operation phase of the aircraft, because it is where we produce our major impact on the environment. But do a fair assessment, include the impact of infrastructure, and remind yourself if we're talking about something that is replaceable. So when we have helicopter travel in remote regions, long distance, very, very long distances, would the car actually be an alternative? Then remind yourself that you matter. Think twice when packing. Every kilogram that you pack into your backpack will be added to the overall weight of the aircraft, and with the overall weight of the aircraft is calculated to know the amount of fuel. So for every gram of material that you pack that is not necessary, we're adding a little bit of fuel to carry that around. Just remind yourself of it. And we, the aviation industry, know when flying doesn't make sense. And we have a very good, here in Germany, a very good example from that for one of the major commutes between Cologne, Bonn and Frankfurt, where Lufthansa actively developed together with the Deutsche Bahn a high-speed train connection. For the aircraft itself, the composites enable a lighter aircraft, and that is due to the heavy impact of the operations phase, the crucial impact that we can bring to the table. Composites are lightweight, and we make the aircraft lightweight. And by now, composites can be recycled, and high performance applications have been shown and are in development. And due to the major discussion that is going on, biomaterials have their place, but it has to be the right one. Don't just use bio-based instead of an industrial material if you're not sure that you can prove that this is actually beneficial. Bio-based in itself is nothing that brings benefit to the table, or not in the sense that it's been talked about. And developing a circular economy for composites is possible, but we need more work. We need to improve the segregation, which is homework for all the producers of waste. We need to actually target, and this is what has been called out within Airbus. We are targeting 100% recycling. We're not going to do any landfilling, even in the countries where they would allow it. We will not landfill CFRP waste. And we should avoid downcycling. And personal opinion, we need to work a little bit more on technologies for material recovery on an elemental level, since that is the most common denominator between all these, what these materials are made of. Yeah, and I think, no watch in sight. I hope you had a little bit of, this was an interesting peek into how we think about this whole area of sustainable aviation, how we think about it in terms of composite manufacturing and how these two major keywords kind of relate. And with this, I will thank you for the time. Thank you for coming here and spending the time to listen.